Activate Weird Science Fair. Run experiment Elephant Toothpaste.
Hi everyone, my name's Andrew. I'm one of the environmental educators here at Clay Pit Pond State Park Preserve. In today's Weird Science Fair experiment, we're going to be making elephant toothpaste. To do this, we're going to need a few things first, such as dish soap that's not antibacterial. Antibacterial dish soap could have a negative effect on our reaction. Yeast. You might want some food coloring. You're going to need some water, along with some hydrogen peroxide. Hydrogen peroxide can be picked up at 3% at basically any store. But you might want a slightly higher percentage, like 7, which I'll be using, which you could get at a place that sells hair products, and you can find it online. Next, let's go over the measuring equipment we're going to need. You're going to want a measuring cup and a table and teaspoon measurement. I have another small one to mix things in, but this is because it has a spout, which will become important later. I have a pipette and an eyedropper. You could use either one, and you might not need it. We'll talk about that when we get to the food coloring. Lastly, for physical equipment, you need a bottle. This could be a soda bottle or a glass bottle like I have, and a tray to collect what happens during a reaction. Finally, we're going to need some personal protective equipment, which includes goggles or safety glasses and gloves. I'll put these on in a second before we start the reaction, but it's very important to have these on. High levels of hydrogen peroxide that we'll be using can cause burns to your skin, along with damage your eyes if it gets in there. That's why we need to be careful and use our safety equipment. Alright, I'm going to put this on and we're going to get this reaction started. Here we go. Okay, now that I have my personal protective equipment on, we're ready to get started with this reaction. The first thing we're going to do is activate our yeast. To do that, we're going to need to put 4 cups of very warm water in with 2 tablespoons of our yeast. I'm going to do this in this measuring cup because it has a nice spout on the side, which will help me pour it into our bottle later. Alright, let's add our 4 tablespoons of very warm water. There's our 4 tablespoons. And next, 2 tablespoons of dried yeast. There's 1. And there's 2. It was a little bit under, so I'll just shake the rest out into there. Next, I'm going to use this fork just to mix it all together. So this warm water will start helping activate the dried out yeast, which is basically asleep right now. Alright, so you should get this really cloudy looking water, which is perfect. And I'm going to set this off to the side here so that yeast starts activating more. Next, in our bottle, we're going to add the hydrogen peroxide. Remember, this is the chemical that can be dangerous, so be very careful. I've already measured out 1 cup of it, which is the amount we'll be using, in this measuring cup, and I'm going to pour it into my bottle carefully. Great. Now I'm going to add 1 or 2 drops of soap into our bottle. There we go. I'm going to add a little bit more just to be safe. Great. Now I'm going to gently swirl it. Now remember, this can be a dangerous chemical, so we want to be careful about how we mix these together. So as you can see, I'm just gently swirling it to mix them together. You might see a little bit foaming on top, and that's fine. It's just the soap reacting with some of the water that the hydrogen peroxide is stored in. Great! Now that they look pretty thoroughly mixed, I'm going to add food coloring. Like I said before, you don't have to add food coloring, but I'm doing it to make it look more like toothpaste when it comes out. To do this, I'm going to put some food coloring in this tablespoon measurement. Use my pipette to suck it up, and then make a few drops along 2 of the sides. So I'll put 1 over here and another over here. Well, It looks like my water is still spinning a little, so it might not have the exact effect I want it to. but it still will look pretty cool. All right, once we do that, we're ready for the experiment, or for the reaction. So let's go ahead and clear some things out of the way. Grab our yeast, and on the count of 3, we're going to pour it in. Once you pour it in, you want to get away from the back, so I'm going to step off to the side, just in case it sprays more than I expected, okay? Here we go. 1, 2, 3. Whoa! Wow, that's a lot of foam. Look at it go. Now, when this foam comes out, there's a chance for it to be hot because of our reaction, and we'll talk about more why later. But if you feel it, and it doesn't feel warm, you can play with it. Mine is still a little warm, but it's not hot. It's not going to hurt me. It's so fun. And it smells really good. All right, we're going to let my reaction keep going for a little bit longer, and we'll get back in a second. Okay, I moved my reaction to the middle of the table and took off my personal protective equipment so we could talk about why this happened. Hydrogen peroxide is 2 hydrogen atoms and 2 oxygen atoms in one molecule. But when this molecule is exposed to light, they break apart, creating H2O, which is water, and O2, which is oxygen gas. This reaction, though, normally takes a while, so we added yeast. Yeast produces an enzyme that acts as a catalyst. A catalyst is something that makes a reaction happen a lot quicker than it normally would. So in this case, when we added it to this bottle, it reacted with our hydrogen peroxide to make the reaction happen a lot quicker. This produced a lot of oxygen and water very fast. Because of this, the oxygen trying to escape the liquid got trapped in our soap and made a fountain of suds. By the way, did you feel our bubbles? Did they feel warm? Mine sure did. This is because this is an exothermic reaction. An exothermic reaction is when the molecules break apart and produce energy, and this time, in a form of heat. You and I do this all the time. Whenever you use a lot of energy, say go for a run, do you feel warm? I do. It's because when we use energy, we also produce some heat. You might have noticed this. Your body shivers when you get cold. This is because it's using this energy to keep warm. Animals that do this are called endothermic animals or warm-blooded. Some examples of this are birds and other mammals. Well, I hope you learned something today doing this reaction, and you enjoyed today's weird science fair experiment. I'm going to put my personal protective equipment back on and clean it up. I hope you have a good day. Bye.